Okay, so we got u1 is 1, u2 is root 3, u3 is 3, u4 is 3 root 3. So each time is a times in by root 3. So actually that's root 3. This one we could consider that equals root 3 squared. And here equals root 3 cubed. And u5 will equal, that will obviously be, times that by root 3, that will be 3. That will obviously be 9. And that we could say is root 3 to the power of 4. And we've got to work out u6, but I can work out u6 anyhow. u6 times that by root 3 will be 9 root 3. But I could say it's root 3 to the power of 5. But anyhow, I've got it here, it's 9 root 3. Or if I do root 3 to the power of 5 on a calculator, I would get 15.588457. But I want to see the link, so I don't want to have to keep on going to get 9 and 21. So I'm now looking at the link between this each time. I've made it into powers. When it was 3, that was squared. When it was 4, that was 3. When it was 5, that was 4. So all I have to do is just take one away. That's going to be okay. So u9 will equal root 3 to the power of 8. Do it on a calculator. And that's 81. I could have known that anyhow, because 2 of them together will make 3, and then another 3, and then another 3, and then another 3, each of those being a pair. Root 3 times root 3 is 3. 3 times 3 is 9, times 3 is 27, times by 3 is 81. And I need 21, so u21 will equal root 3 to the power of 20, because it's 1 less, as we just seen. And that is 59049. Good. And now we've got the first 4 terms of a quadratic sequence. It's told me that. And as you can see, so it's a quadratic. It's going to be it says an squared plus bn plus c. So it's given us that. I've got 3 things I've got to find out. That means I need 3 equations. So I'm going to have, and I always like starting with if n equals 3. And the reason I do that is when you'll see when I start subtracting them, it'll work nicely. So I'm going to, if n is 3, then I know the third term is 28, but I could write it like this. A times 3 squared, that's a times 9, or I'll write down 9a obviously, plus b times 3, that's plus 3b, plus c, that's the formula which I'd get from here, but we know that that equals 28. So that has now given me one equation. If n equals 2, chuck it in here, n is 2, that would be 2 2's 4, so it'll be 4a, plus n is 2, so 2b, plus c still, and that's the second term, which is 14. And then finally, if n equals 1, then I get 1 squared is 1, that's going to be just a plus b plus c equals, the first term is 6. So that's what I've got now, and the reason I quite like doing it the sort of the opposite way around is because I only can get rid of the c's now by subtracting. And if I take those first 2 equations and subtract, then what's going to happen is I've got 9a's take away 4a's, and I'm going to get 5a's, and it's nicer to do the bigger one at the top, so that's why. So that will give us, I'm subtracting the top 2 equations, and that will give us 5a's plus a b. There are no c's, and that will equal 14. And then I'm going to subtract these 2 to get rid of this c's, and that will give me 3a's plus b equals 14 take away 6 is 8. That's great. And now I can get rid of these b's by subtracting. So I'm going to take these 2 equations and subtract them, and that will give me 2a's, no b's, equals 6. 14 take away is 6, and therefore a equals 3. So I've got a equals 3. I can put that into here, which will give me 9 plus b equals 8. That means that b equals minus 1. So b is minus 1. And then I'm going to put the a equals 3 to there. and the b equals minus 1 there. So give me 3, take away 1, plus c equals 6. So that'd be 2 plus c equals 6. So obviously c equals 4. And this way will always work if you do it like this. Start with n is 3, 2, 1, and then you'll always find that the c's will disappear, and then the b's will, and it'll leave you just an equation a, and then you can cascade it through. And this is quite a nice layout when you can see we're combining them. Hopefully that makes it fairly clear what's going on. And that's question 15 and the whole paper done.